Assalamu alaikum. My name is Syed Tayyab Farooq, and I, with my partners Ali Ahmed Khan and Minhaj Ahmed, under the supervision of Sir Farhan Ahmed and Dr. Ali Ahmed at MERL-UIT, have created an UIT edition RISC-V Instruction Set Simulator for our BURAQ Core chip. It supports three extensions of RV32, which is I, M, and C. We have named it Oxygen. This is the landing page of our website. It is an open source website built using Python Django. So let's dive into it. This is the editor interface of our website. As you can see at the top of the page, there are three tabs: BURAQ I, BURAQ IM, and BURAQ IMC. BURAQ I only supports I extension. BURAQ IM supports instructions from both I and M. BURAQ IMC supports all of the three extensions, which is I, M, and C. It is an intelligent editor, which means that if the user writes an invalid instruction, it generates a red line under that instruction, indicating that there's something wrong with the instruction. And if you take your cursor over it, it will generate a message which shows the user what is wrong with the instruction. But even after this, if the user decides to start simulation, the simulator will generate an error showing user the error with the instruction and the line number in which the error has occurred. So let us now demonstrate how the simulator will work if each of the instruction is correct. As you can see, none of the instructions here shows any sign of any error. So let's just go and start simulation. Clicking on the start simulation button will direct you to the simulator page. At the top of the simulator page, you can see 5 buttons, which are run, step, previous, reset, and dump. Run will execute all of the instructions at once. Step will go over each instruction one by one. Previous will take you a step back. Reset will start the execution from the beginning. And dump will generate hex of the instruction, which can be used for verification purposes. At the top right corner of the page, there are 2 tabs: register and memory. Registers will show you the register specification, and memory will show you the memory specification. As you can see here, the instructions are loaded into the instruction memory, and we have a variety of display settings such as decimal, hex, unsigned, and ASCII. So if I select hex, the format will be converted to hex. Let's and this part here is one of our unique functionalities that we provide in our simulator, which is that we demonstrate each of the instruction according to its instruction format. So for example, is an I type instruction here. So this is its PC counter, basic code type, and if the instruction contains immediate 1, its immediate 1 value will be shown here. If it contains func7, which this instruction does not, but if it does, it will be shown here. Func6 and func4 are the instruction format of C type instructions, so they will not be used in I type. So as you can see, all of the instruction does not contain func6 and func4. If the instruction contains RS2, it will be shown here. RS1, func3, func2, RD, immediate 2, and opcode. Func2 is also part of the C extension. And so you can see that none of the instruction contains func2. So let's just go over the instruction one by one. So if I click over the step, the step button, it will execute the first instruction, and you can see that first instruction has been executed and the value has been saved in the register. So we can go over each instruction by using one by one by using step, and the and you can see that after each instruction has been executed, it's the value, if it stores a value in the register, the value has been stored. And we can use run also to execute all of the code at once, and you can see the code has been executed, and uh, a, mer- a message was generated in the tab in the bottom right corner indicating that error, indicating that the code has been successfully executed. You can use the reset function to start the execution from the beginning. So see here that all of the registers are uh, are changed back to their original value, and the simulation has been started over. So when so if you run all of the instructions and then create dump and then press dump button, so here you can see the hex generated by the dump. Okay, so this is for I extension. Now let us go and see. So here is a test instructions for BURAQ for I and M extensions, and you can see it contains instruction from both the extension, like add I is from I extension and MERL-HU is from M extension. Let's just go and start simulation, and now we are directed to the simulator page. So the thing that I was talking about in the previous demonstration of only I extension, about the func6, func4, and func2. Sorry, it's related to C extension. So we will get to see this in when a C instruction is executed. So let's just go step by step over each of the instruction. And as an execute, the values change after each instruction has been executed. And if you want to go back one step back, you can use previous. So you can so as you can see, I move back two instructions and value has been nullified. I can go step forward, and if I want to go back, I can use previous. Stop कर देना Ali, कर दिया कर. So we can use step and previous to go back and forth between the instructions. We can also use display settings to see the register values according to our desired format. Like I can choose hex, and as you can see, the values have been converted to hex. If I want to view it in unsigned, I can use unsigned. If I want to view it in ASCII, I can use ASCII. So let's just stick with decimal. So once again, we will click on the run button to execute all of the instructions at once. So you can see there the message, success message has been generated, code exited with 0 error. And if I want the hex of this instruction, I can click the dump button and copy it from here. Okay, so now let us demonstrate the IM and C extensions all run together. So let us go back to the editor interface and select the BURAQ IMC tab. And I have already inserted some text examples from all of the three extension, which is C, I, and M. So C.ADI is from C extension, MERL-HU is from M extension, and sub is from I extension. So let's just go and start simulation. And now we are directed to the simulation page. So so here you can see. So C extension is of 16 bits. So it's func3. Its its format is a bit is comparatively smaller than as compared to the I and M. So as you can see, it's func3. So this instruction does not contain uh, and func6, but so see this instruction. See C.mv. This instruction contains func6, func4, and its func4 has been displayed here. C instruction is a 16-bit, so its format is a little bit different than I and M. And once again, we will go over each instruction one by one first to see if it's working. And as you can see, the value. So if the user wants the hex of this instruction, he or she can just click on the dump button and the hex will be generated. And one thing that you can notice here is that a hex of the C instruction is comparatively smaller than an I instruction or a M instruction. This is because C instruction is of only 16 bits, while I and M are of 32 bits. So this was the total demonstration of our product. Our simulator can also be used for educational purposes to teach the students about the ISA of RISC-V, and it can also be used for verification purposes. One unique feature of our simulator is that we have added C extension, which has not been added in any open source web-based simulator, web-based RISC-V simulator. These are our contributors, which have contributed in developing this simulator. This is all. Thank you for watching. I hope you like it.